Hey everybody, my name is Hudson Jameson and I'm here to talk about an IoT security startup called Oaken Innovations. Let's start with me real quick. My name is Hudson Jameson, like I just mentioned. I've been involved in blockchain since around 2011 in college, messing around with some Bitcoin stuff. For 2 years, I worked in the banking industry at USAA, leading their blockchain innovation program. And then I left there to kind of do my own thing, work with the Ethereum Foundation, which I still support today when I can. And then with a group of really, really cool people, I started Oaken Innovations 2016, 2017. I have a beautiful wife and 3 cats, so if you like cats, I like you. This is the great team I was talking about, John, Laney, Lex, and James. All of us together make up Oaken Innovations, and we're really excited to explain why we're securing IoT with blockchain. For anyone who wants to follow the slides, go to Twitter and go to @HudsonJameson, and my slides are posted there so you can follow along. So what we're doing at Oaken is we're building a secure blockchain and IoT platform. So what that means is we have all these IoT devices that are inherently insecure, and what we're trying to do is smart cities are coming up, autonomous driving cars are going to be coming in the future, and they're going to need a layer of security that is pretty much hack-proof. Here's some examples. Some, I guess, comical example on the left is that someone's IoT oven broke, and so it's raising in temperature way, way, way too high. But the more serious one is that hackers can remotely kill these IoT-connected smart cars and these self-driving cars that are coming out. So we need something that uses a public key infrastructure in order to secure these devices. So we've developed a platform that's a combination of hardware and software tools in order to secure IoT devices. We use a number of software tools, including Ethereum, which is a blockchain system, IPFS, which is a decentralized distributed storage solution, Node for some of our front-end stuff, and then, of course, Raspberry Pi with a lot of cool hardware goodies attached to that. All of this is secured by a secure hardware module, tamper-resistant. We're still kind of working on some prototypes for that, but it's a really, really cool field to be in. So I'm going to just show some process shots right now. What we did recently was a project with Toyota, and what we were trying to do was say, there's all these distributed, decentralized technologies and blockchains, but how do they really work? Is this actually going to be useful? So what they said was, okay, we're not going to get into this business, but let's make a car-sharing app, or DApp, distributed application. And let's demonstrate how we can use Ethereum and how we can use IPFS to make a really, really secure, decentralized solution. So what we did was we took a Prius and we tore apart the key fob. We didn't really tell the dealership about that. I don't need to go into that part. But we took apart the key fob and we connected it to the Raspberry Pi. You can see the key fob there connected to the Prius Prime through the Raspberry Pi. In the future, what we envision is with our IoT devices having a secure box around the IoT device, so it's not an exposed Raspberry Pi, but an automotive-grade hardware device with a hardware security module encompassing the private keys that are stored on the device. So I'm going to just walk through the car share demo, kind of explain what it does, what tools we use to build it. So what we were trying to do, the whole point of this is to cut out the middleman. That's what blockchain's all about. So what we did was we disintermediated Hertz. And I know what you're thinking, Turo has already done that. You can do kind of peer-to-peer car sharing over Turo, but Turo still takes a cut of that money. So why should we have a middle party if you want to share your car with another friend or someone you trust, and you can have these new blockchain reputation systems that make trading your assets or locking your assets secure? So we built this in collaboration with Toyota. The back end was almost entirely decentralized technology. The one exception was we had to use a pub/sub protocol in order to quickly lock and unlock the car. But recently, IPFS has come out with a new tool that's going to make that a lot easier. We used Ethereum, MetaMask, Infura, Solidity, IPFS, and MQTT, which is a in-house product that we're doing for secure pub/sub signaling from the car to the user's phone. So that first page was just a welcome screen. Now we're actually at the rent-a-car screen, where you can go and you can see cars in your area that are able to be rented. You log in using your Ethereum account, which is just a public-private key. Anyone who's had a blockchain wallet can understand that jumbled up mess of letters and numbers that make up your wallet address. What we did was we put one of those addresses on the box in the car, and that gave the car its own identity. It's now its own entity that can interact with smart contracts and pay for itself going through tollways or schedule itself to be rented. This public key cryptography makes these self-sovereign identity use cases really, really exciting. It pushes the security client side, so you don't have a traditional infrastructure that stores your keys like if you're logging into Google. The hardware, like I mentioned, was a Raspberry Pi, GPS antenna, and a hacked key fob. The front end was a React Native app. We had to build a custom IPFS React Native component for that. And all of the data about the cars and the data about the people who are wanting to rent their car are stored in JSON files that are nested in IPFS. So we use this decentralized storage because it's a lot cheaper to use IPFS for ephemeral storage than it is to, spin up an AWS instance. It's also, backed up all around the world, so it's a really, really neat way to have semi-permanent data that you're using for a short amount of time. We also had Google Maps, of course. We used the Ethereum network and IPFS to connect all the data points together. Now we're at the point where we've actually rented the car. So let's look at the back end here. We used Ethereum smart contracts, and I know a lot of people are wanting to put everything on a smart contract, and that is very costly in terms of transaction fees and blockchain bloat. So what we did is we had a few simple functions in there, and they dealt with payment and authorization. When you wanted to rent the car, you would pay for it in Ether, and what that would do is they'd take your phone's address that we set up for you using Status or MetaMask or whatever program you're using, and you've reserved the car, so now you get put on this authorization list. So now, once you paid for it and you're on this list that says between time X and time Y you can rent this car, whenever you need to unlock the car, you push the unlock button and it's a simple blockchain read. We were able to push that unlock button on the phone and the car would instantly unlock, just like if you were using your car keys to unlock your car. And even though there's block time concerns with blockchains, as long as you're designing these things with the idea that you're not putting everything on the blockchain and you're only putting the most needed logic and authorization on the blockchain, then things are going to be a lot easier for you as you're building your dApp. MQTT is our take on MQTT. We modified it to support Ethereum signing using public-private keys. So the user, when they hit the unlock car button, would send an Ethereum signed transaction to our Raspberry Pi in the car, and the Raspberry Pi would go, okay, let's check, is this transaction actually signed by this address? It would say yes, and then after it says, okay, this is legit, it looks at the blockchain and says, well, now can it unlock the car? And then that quick blockchain read locks the car or unlocks the car, whichever one it sends in. The value of this Acorn technology is that you can have this public key infrastructure set up to secure your IoT devices, smart cars, smart homes, and because of the fact that you can use HSMs to secure your private key, it makes this impenetrable little device that can have an identity, that can have value, that can store and transfer value, and that can act on its own using these smart contracts. You can think about car owners monetizing excess capacity, like a carpooling app. Maybe a data market that the cars share data with vendors and the drivers make money from that data being shared. And of course, like a Carfax-style car history is another one that would be really interesting to have this IPFS component storing data on the blockchain. So there's a kind of a map of where Oaken's going to be. We're really busy this month, so we'd love to come out, for you guys to come out and see us. There's my information, my Twitter and the website. Come check out our website. We have a lot of cool videos that explain this in a little bit more detail with some nice images of me driving around in a car. So go ahead and take some pictures. This is my contact information. I've had a great time talking to you guys today. Come find me. I'll give you my card. Thank you.